This is where the power comes into the motor. There's a cooling fan. There's air cooling fans, but there's also a liquid cooling fan because I mentioned that. The stator stays. Electrical energy goes into the stator and causes the rotor to rotate. So inside every motor, electric motor, there's these series of copper windings wrapped around metal. Gasoline and petrol vehicles work on a series of controlled explosions to basically move and propel your vehicle. By comparison, electric vehicles work on the principle of magnetism. The north pole of one of magnet to the south pole of magnet, they will what? Attract, right? But if you put the north pole to the north pole of another magnet, they'll push it away. All right? So that attraction and that pushing away is how the motor in an electric vehicle works. So the stator stays, electrical energy goes into the stator and causes the rotor to rotate. And this output shaft goes into that gearbox I told you, and then power goes to the wheels. Much more simple to use magnets than explosions. This is where the power comes into the motor. There's a cooling fan. There's air cooling fans, but there's also a liquid cooling fan because I mentioned there's a thermal management system that goes along with it. And here is basically where the motor mounts to the chassis of the vehicle or the structure of the vehicle so that the propulsion actually happens on the vehicle and it just doesn't stay still. Whenever you so there are magnets that we talked about that you remember in school, those tended to be permanent magnets made out of rare earth materials, okay? That's one way to get a north pole and a south pole that either attract or repel. The other way to get a magnet is to flow electrical current through a wire wrapped around a metal. You wrap a wire around a metal and you flow electrical current to it, you'll get similar poles that are north pole, south pole that allow attraction and repel, push, pull, that causes the rotor to rotate. All right, so inside every motor, electric motor, there's these series of copper windings wrapped around metal that create magnetic fields. And this part here that just stays here, it's stationary, it's called the stator. So electricity flowing through the copper wires creates the magnets. The positioning of the magnets makes the shaft spin. The fact that this is a push and that's a pull, and this is a push and that's a pull, and this is a push and that's a pull, and the inverter decides whether this is a push or a pull because it's sending the electricity exactly where it wants, exactly where it needs to be, hundreds of times per second. It's such an advanced technology, it does that. It allows this push-pull to happen many times. But that's just the first part. The other beautiful part about this is after you stop flowing that electricity, what do you think makes the electricity flow? You push the accelerator, right? In a gasoline or diesel vehicle, pushing the accelerator with your right foot causes, in the old days, it was actually a spring and a cable, but in more modern vehicles, it moves a switch called the electronic throttle control that actually puts gasoline or diesel into the intake chamber, mixes it with air, and then you get your explosions, your controlled explosions. In an electric vehicle, that same pedal determines how much electricity is flowing from the battery to the inverter to the motor control unit into the motor. Okay, so that determines how fast, just like it does in your old gas and diesel vehicle, it's determining how fast or slow the vehicle can go. But the beautiful part about that, in addition to that, is after you take your foot off of that accelerator and you stop flowing that electricity into the inverter, into the motor control unit, and into the motor to cause the push-pull to happen, to cause the north and south poles that cause the rotor to spin. Your vehicle, just like on your gasoline vehicle, you get off the gas, the vehicle's still rolling, right? because you haven't pushed the brake yet. You get off the accelerator, your vehicle is still rolling. This ends up, the electric motor ends up becoming a generator. And it has the forward motion of the motor turning and your wheels turning to create energy. To generate energy, because it becomes a generator, and it takes that energy, the inverter says, send that back to the battery so we can use it again in the future. Send it back to the battery so we can use it again to the future. You have a motor in the front, 2 motors if it's 4-wheel drive. Remember, a gasoline engine had 1, but with a transmission and a transfer case, sending power to the rear wheels or to the front wheels. In the case of an electric vehicle, you have a motor in the front and 1 motor in the rear. You have your battery, so they call this the traction motor. You have your power electronics controller. I'll talk more about these electronics, such as the DC to DC converter, the thermal system. Anyone ever used a laptop and it got a little hot? Okay, so electronics devices get hot over time. Devices with batteries get hot over time. So there's still a thermal system in an electric vehicle, but its role is to manage the heat generated from the power electronics, which I'm going to talk a lot about later. Also manage the heat from the battery, because a battery is a series of chemical reactions that create electricity. That's what a battery is.